ZombieTech. Welcome to ZombieTech, a forum for engineers, scientists, and inventors to ponder on the technologies needed to survive the inevitable zombie apocalypse.
She's Eddie.
He's Whisker.
And this week we're talking to, well, somebody that you have probably been listening to longer than you have been listening to us.
Oh, yeah.
Mr. Chris Gammell from the Amp Hour.
And I'm Chris Gammell from Chris...
From a whole bunch
different
of
podcast,
things.
right? Oh, different podcast.
Yeah.
You have a whole bunch of things, actually. You have...
I do, yeah.
The Amp Hour podcast, right?
Mm-hmm,
You have engineeringblogs.org.
And engineer blogs.
Blogs.
We didn't buy engineering blogs. We probably should. Someone else is going to snap that up.
Well, no, that's fine, because...
There's a squatter opportunity out there.
Yeah,
For
did
someone.
you hear that, guys? Go buy it today.
That's right. Only, $1.99 on GoDaddy.com, and you can make millions.
Yeah, off of a couple of people who...
Bunch of people that
write
don't get paid.
blog. Yeah, because they're loaded.
Nice.
This blog and podcasting thing's where all the money is.
Oh, yeah. Can't tell you. You know, I replaced my chair with just a big old bucket of money. Like Uncle Scrooge style.
Just sitting there, just throwing coins whenever you feel like it.
Right, exactly. You know,
Nice.
Electronics wasn't doing it for me, so I thought blogging and podcasting. That's really what the
How
money
does your
is.
wife think about the coins that are strewn all over the floor?
She's pretty mad about it, but we're getting through it.
Well, yeah, that's right. We had to schedule this podcast around a wedding, didn't we?
Congratulations!
Oh, thank you. Yes, I'm 3 weeks in, and I'm still
Wonderful.
alive. And,
Wonderful.
Yeah, and I was telling people on the show last night, actually, she's learning how to code, so she's picking up my nerd ways, and I'm picking up on her softer side ways, you know? So it's all working out great.
That's very exciting.
And it was Python that she was starting to learn, right?
Yeah. Yeah. Do you guys code in Python at all?
I've looked at Python a few times. I
Yeah.
code in a bunch of other languages. It's kind of a nice little toy.
And I'm kind of like your wife in that I have never, well, I don't know about her, but I have never had an interest in coding.
Mm-hmm.
But because of Whisker, I'm looking into spin. So,
Spin. What's spin?
for the propeller.
Oh, okay.
Yep,
Okay.
Yep. So
Cool.
I've started a little bit with that, just some LED,
That's
know,
good.
tinkering and,
It's interesting to see somebody who has no coding experience whatsoever, and their first experience is on an embedded platform.
I think that's a better way to do it because LED lighting up is like infinitely more powerful than, you know, Hello World showing up on a console, you know?
Yep.
I love the LED test.
I also
it's really
think it's very... I like it because coding for something like that is a lot more like what I started on, the Commodore 64. It's so much more limited of a platform, so it's like you can understand the whole thing.
Yeah. No, I've said that before too with on the music side of things, you know, like I hate people that like get the best guitar they can possibly get like right out of the gate, you know, like if someone's just gifted a really awesome guitar or something like that, you have to learn on a crappy guitar first so that when you get a good guitar,
You know how
then
to
you're
use
like,
it.
"Oh my god, this is like gold in my hands," you know? Like that's the kind of thing you need. You need that, you know. If you start with the best, you're just gonna I don't
take
know,
it
it's
for
not-
granted.
Yeah, exactly.
Yeah, that makes sense. So yeah, I mean, I'm not doing Python, but I'm doing spin, and it's interesting coming from my perspective because at least I think a lot of the ways that people explain how to code is very stupid to a non-coder.
Right, exactly. If you don't have all those things in your head already, right?
Exactly. I mean, what's the point of teaching somebody to code in coder language? It just doesn't make sense. Anyway.
It's one of the most difficult part of it is just getting past the language barrier between a normal human and a computer science major. You know,
Yep.
I'm self-taught, so I only understand about 30% of what a CS major has to say on it. Or a
Right, they
software
start
engineer.
diving down into data structures and all of that other like academic type
They
stuff.
have their entire own language for discussing the topic, and it's like I understand how it all works, but I have my own ways of thinking about it, right? And it's even more removed for you because you've never thought about it at all.
Correct.
That's interesting because a lot of people suggested learn Python the hard way, .org. It's like a book. You can just look at it online.
It's a
or
clever
That
name.
sounds inviting.
yeah, right. But then you read the first chapter, and it says basically the hard way is the way they used to teach it, where you copy it. You're just kind of getting muscle memory. Basically, you're looking at
Oh, yeah.
existing code. You're typing into a script, and then you're running it in a console, and you're just going through the motions, and you're learning even when you copy something wrong. That you missed a semicolon. I don't think they use colons, I think, in Python, but you missed something really critical here, and then you naturally will teach yourself, oh, that's why, and you kind of get a feel for the language. So
It's a bit like learning to spell by typing all day long with spell check turned on and it turning everything right on you all day long.
I guess.
yeah, I guess that's a good analogy. I guess I don't know if that would be the best way to learn language, but I think in this case it seems like a really good resource. I mean,
Sure.
it's
It's,
just kinda
better
a
than
good
nothing,
grind.
I suppose.
The guy compares it actually to bring it back to guitar. He compares it to guitar and just like practicing scales every day, just kind of the rudimentary need to know how to do it kind of thing. And I like that. I mean, there's similar things in electronics, I think, too. I think there's soldering and wiring things up and knowing just how to look at a schematic even and be able to work a signal chain. That's pretty important. So
Yeah,
I like it.
looking at a circuit when you're starting, it's very mind-boggling, and you're like, how in the world can anybody make sense of this? But you look at them enough, and you're like, oh yeah, I understand what that cap sitting across those rails is doing. That's
Exactly.
obvious.
Yeah, and you start to kind of zoom back almost. Like I work with a lot of op amps, and I remember
You're
the
like
first
the
time.
op amp guy.
No, my
Well-
coworkers are the op amp guys, but
See, I searched for op amp, and your blog was the first one that came up. And
that was on purpose. That was back when I was going to make money with my blog. That money.
well, I'm pretty sure I clicked an ad there for you. So,
You only need so many bucket chairs, though.
so then, actually, speaking of schematics, you are an analog electrical engineer.
That's right. Yeah.
Can you tell us a little bit about what that is? And I don't know what the difference is between that and a quote unquote normal electrical engineer. I just kind of assume that all electrical engineers
The difference
do
is
analog.
that Chris actually knows what he's
Analog.
doing. The rest of us
No.
just kind of
No, that's
pretend.
not true. No. That is not true. I'm sure some of them. It's funny. I talked to some of the listeners of the Amp Hour, and there's this one guy, Philip, and he's this really nice guy. And he's like, "But man, sometimes you guys are just so wrong." And I'm like, "Yeah, I know." And it's like, well, of course we're gonna be. I mean, we're human, whatever.
Right.
I'm 5 years into my career, basically. Yeah, I'm fine.
It's a nice thing about this show. We're not the experts on this show. Whoever's the guest is the
Is the
expert,
expert.
so we can be wrong.
That's what we're doing wrong.
all day long. No big deal.
Yeah. The analog side of things, I mean, I don't know. Electrical engineering is just such a big field. It's interesting to look at. I mean, especially like if you talk to like someone who's studying, like going back to school or in school and talking about electrical engineering, they could be anything from hundreds of kilovolts, doing power line stuff, or measuring picoamps, right? And you could be on any area there. It's just a really broad spectrum. So and then there's analog, digital. Usually RF is separated out. CS is a whole different field, really. But I guess there's firmware is probably rolled in there too. I mean, that's the thing. A lot of school programs, they start to merge electrical engineering, which is usually the circuit level, and then like computer engineering, they say is like FPGAs and microcontrollers and low level hardware, and then computer science is a higher level software.
And so
So
where does
in-
analog fit into that?
Yeah, so analog fits in the circuit level side of things, but
Okay.
the difference would be instead of logic gates and stuff like that, it would be op amps and usually the analog realm is everything before an A to D, which is rapidly shrinking these days. But if you have a signal, you're trying to measure like the current through a resistor, right? So you have a sense resistor, and then you want to measure that with an op. You put an instrumentation amp across a sense resistor, so you measure maybe there's 4 volts going through a 1 ohm resistor, so there's 4 amps going through that resistor, and then you can maybe scale that down if you need to, so that you'd have a secondary stage where there'd be some kind of attenuation, and then you push that into you condition that signal, you put it into an analog to digital converter, and that might involve making it a single-ended to differential, yada, 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 and eventually it goes to a microcontroller or computer, and then you can have like a readout of some kind.
Okay.
So everything before the A to D is kind of the analog side of things.
Gotcha. So then, how do you? I know you have, or you started a company last year. Was it
a consulting company? Yeah,
consulting company. Called Analog. I gotta get the name of this. Analog. Help me. Life. Yes, Analog Life LLC.
That's
and
right.
I guess given that you work on the circuit board side of things before the ADC.
Mm-hmm.
Yep, before the ADC. What is it that you usually do then, like for your clients or what have you?
Well, one of the things I was working on was just a low current measurement circuit, really. I mean, it was measuring light out of a CMOS sensor. So in that case, like it was detecting different wavelengths of light, and then we were conditioning that analog signal. So in that case, so maybe that's a good example of where you'd have analog versus digital, right? Sometimes if you had a CMOS sensor that was sensing light, sometimes you'd actually have all the circuitry on the chip where it would output just a digital stream in I2C or SPI or anything like that. In this case, though, it had an analog signal output, so it had an infinite resolution, really. So if it could go from 0 to 10 volts, I don't think it did, but if it could go from 0 to 10 volts, there's infinite numbers of, there's an infinite
range
amount of data you can have in there, right?
Sure.
And whereas if it had a digital output, then it would have a very discrete amount of data. It might have 10 bits of resolution, 20 bits of resolution. So the difference is you kind of push off that going from analog to digital to much later, so you can actually do some kind of processing on that. And the reason that's important is because at low levels of current, which in this case it was, you have to gain it up somehow. You have to be able to account for a lot of different variations of that analog signal. The analog signal might be changing faster than a built-in ADC might be able to do it. So there's a lot of fun things there.
So then
you would get all sorts of strange harmonics, oddness if your ADC was running at a frequency that was landing at a harmonic to like a 60 hertz light in the room.
Right. Yeah. If that wasn't built into the front end on the chip, then yeah, you'd be screwed there. Now, interestingly, a lot of stuff is moving that way. I mean, it's all kind of moving on chip because it's cheaper, and a lot of the chip vendors that are making this, so like in that case, the CMOS sensor people, they might be able to push some op amps and analog to digital converter onto that chip and charge $20 more for it, because then it's just this module that detects light, and then it shoves it over a SPI bus into a micro, and the engineer that is strapped for time is just, heck yeah, I'm just going to put that in there. It's awesome.
It's nice to be able to work with a black box solution like that, but
yeah,
at the end of the day, you don't know what's really, really happening on the inside of it. And if it's important that every single step of it and how it's going to behave in all situations, then you kind of need to do it from the very, first bit known all the way through.
Right, exactly. And in that case, I mean, to say that sensor is bad, well, your only really option there is to pop it off and put a new one on and hope that one works. And I'm not saying that's not sometimes that is a great thing for like if you're prototyping or if you're doing other things, but in terms of vendors being able to offer exactly what you need, that's not always the case, and that's usually when an analog person is useful.
Gotcha.
So.
Gotcha. So what?
So basically, it's like I said, he's the guy that actually knows what's going on.
No, not at first.
Well, a little experience is always needed. So, what other projects do you happen to be working on? I know you can't talk much about what you're doing for clients per se, but like hobbyist projects or anything that you're working quote in your spare time.
Oh, there's not much spare time.
Whatever little you have there.
Yeah. I mean, really, my big project is consulting for a different client. So,
okay.
That's actually more FPGA kind of stuff. I like FPGAs too. I mean, I think it's really good to know that stuff, and I'm trying to broaden my own knowledge there, just because it's in a world where it's increasingly you need that analog stuff, but at the same time, unless you're really good at it, if you're really good at it, right, you can make $300 an hour consulting for someone doing that kind of thing.
Nice.
I'm not that good at it, right? I'm doing more generic stuff. So I wanted to be able to broaden my base and learn more about FPGAs and actually be a system integrator, because I really like that system level kind of stuff. I want to be able to, design a product from
Start
the top
to finish.
by myself. Yeah, I want to be able to do that.
Now, is that some Jerry influence on you there with the FPGAs?
Jerry is very good at FPGAs, but I actually was doing FPGAs before I knew Jerry.
I see.
It's not like I taught Jerry or anything, because obviously she's very, very good at what she does. But no, I was doing stuff in college, and I was doing stuff at some of my former jobs, and I really like it, just because you can really, you get to be kind of the orchestrator of everything. Then you can talk to the A to Ds, you can talk to sensors, you can change it when you mess it up. That's the part I love the best. I don't know. I've never been big into micros, but
yeah. Well, I think that if you've got the analog side of it and you really want to have a grasp on the technology to the point where you can really build something that's serious, like a seriously useful piece of machinery that is big and nasty, and if it goes wrong, it might hurt somebody. Then
that's what I'm talking about.
if you've got the analog and you've got the FPGA stuff, you're set. Microcontrollers can be a little bit when they error in a bad way.
Oh no! Don't leave FPGAs out of that. I've made some FPGAs.
Oh yeah, if you're not extremely careful with an FPGA, that's just gonna go nuts on you. But if you're good and you know what you're doing with that, and you're also good at the analog, then I think you've got two of the main building blocks that would be required to do something like rebuild society.
Ooh, why would we need that?
Zombies.
Oh.
Obviously, where have you been?
Zombie. Now it makes sense. I get it now. I get it.
Well, so I guess let me ask, because I love analog so much more than digital.
Okay.
Because that's where I started. Because I've been working on getting my ham radio license for the past year, and I went from knowing nothing about anything about electronics. I mean, you talk to me about electronics, my eyes blink, they glaze over. I don't want to hear it. But I started with resistors, capacitors, got into op amps, all that stuff, and as soon as I hit digital, I pretty much took a break from the electronic research for about 2 months.
Really?
And I was like, I don't really want to deal with the digital.
Well, you'll have to do it eventually, but it's...
Well, I did it, but even now I still like the analog more than digital. So anyway, that aside...
There's something beautiful about, the perfect infinity of analog. When you're used to thinking about things in a very constrained 8-bit on and off binary, base 2 sort of way of looking at the world. And, because this is where I started out when I was,
digital.
7-8 years old on a Commodore 64 or whatever. Yeah. And then I did the complete opposite of, the technology. I went from, programming in BASIC to programming in assembly language to working with microcontrollers to, designing analog circuits from scratch, right? Mm-hmm. I went completely backwards looking for my own roots.
Yeah.
And getting there, it's like I see the beauty of the analog now. It's like because you're not restrained, there's an infinite resolution there.
Mm-hmm. Right, which
I fully understand why my tube guitar amp sounds better than my solid state one now. Like I get it. My Hammond organ,
you gotta be careful with the tube
it.
thing around analog people. You'll get some wonky looks, but I think I understand what you're saying.
Chris is making a wonky look right now.
Oh yeah, it's totally.
So in terms of is it, You made me lose my train of thought. Thanks, Whisker.
Uh-huh.
Well, along the lines of analog and the beauty of it, I mean, there's a great piece today actually I posted from EDN. I posted on Twitter though, and there is this guy Barry Gilbert who works at Analog Devices, who's a chip maker, and he just writes this really. I mean, it was kind of the same sentiment. It was like really, just kind of like a Richard Feynman. There's always room at the bottom kind of thing. Like analog is so vast, and the fact that there's a reason a lot of people chose that over digital, even though they were way wrong back when computers were coming up. But like, it's always going to be there. And it's always an important, even if everything goes digital, you always got to get to the real world at some point. So
yeah,
there'll always be need for analog people. And
I always try to explain it to folks as there really isn't any such thing as digital. There's just really fast, really boring analog signals.
Yeah, that's a good way to say it. Yeah.
All right. So Oh no, go ahead.
No, I just said I like it.
Yeah. I remembered what my question was. So you were saying how you like to be on the system side, or system looking down, creating everything from beginning to end. So why couldn't you do that with analog?
Why couldn't you? Well, you could, and they tried that back in the 50s. I was actually looking at. Man, I'm using up all my good links today. Next week is going to suffer on the amp hour. But I was looking for pictures today, and I stumbled across a bunch of analog computing stuff on the Computer History Museum site, and that's what they were doing. I mean, if you think about an operational amplifier, the reason they called it that is because there's summing configurations. There's differential or subtracting configurations. There are multipliers and dividers, but those are a little less common. They're a little more difficult. But like that is actually to do analog math. So before it wasn't, have a binary version of 2 added to a binary version of 2 and get a binary 4, right? It was 2 volts summed with 2 volts equals 4 volts. And it was crazy. I mean, like that's how they did it. So they were doing analog stuff, and even if you look at like cell phones when they started out, that was all analog stuff. But the big problem is power. Yeah. Power is usually where you run into a brick wall.
Yeah, and I think that a lot of that has to do with the fact that the components require, because we don't have components that can really, really get down to the teeny, tiny accuracies like we would like. We don't have ideal components. We have what we can make with what elements we have.
I guess that makes sense.
So to get an accurate reading across a range, it so happens that range has to be from, 0 to 5 volts or 0 to 3.3 volts. Maybe if our range could be like from 0 to, a nanovolt, that might open it up to make analog math not take nearly as much power as it does.
Well, precisely because there's infinite resolution with analog electronics, you would think that somehow we would be able to harness that infinitesimally coolness.
If we had the resolution, the ability to, get down in there and look at the tiniest little sliver of it and treat that as a infinite fold of a fractal like it is.
Well, Chris, I guess you could get on that.
Well, I mean, you can do that today. I mean, you can resolve. I mean, you could do a 0 to 1 nanovolt signal, right? If you wanted to, sweep from 0 to 10 nanovolts, and that was going to represent your 10, and you had like 1 nanovolt steps, if you want to think about it like that.
Yeah.
But the problem there is like noise, and that's another problem in a lot of like it. I always end up thinking about analog cell phones, right? Like why they went away from analog cell phones, and it's just really power hungry. You think about how much it takes to transmit an analog signal. There's a lot of data there. Whereas if you start getting into like Fourier transforms of like an analog signal, you can really chop off a lot of that data and still maintain the important part, and then cut down how much power you need. So and that's why they started going towards digital.
So the main reason we don't harness all that data that you're referring to is because of noise?
Well,
or am I missing I might be missing something. I might be simplifying it, I should say.
No,
But I don't know.
the noise thing is like, so we could do analog math, right? We could do operational. I guess it's two different problems. Like if you were just looking at analog math, you could do analog math where you could have infinite infinite resolution on a signal, right? And you could add two signals together, but there's just so many outside influences there that it's just not worth it, really. I mean, sometimes it is. Sometimes there is a lot of reason to do that kind of thing. For summing nodes on feedback control and that kind of thing, it does make sense. But in terms of like a precision analog math solution, I don't think that really makes sense because you do have noise and you have offsets and you have, stray currents and
Sure.
like parasitics all over the place.
Sure.
So that's why it doesn't really make sense for the math side of things. But for if you're looking at like communication and why we don't do analog communication as much anymore, that's a power thing. Because if you look at like how much power you need to transmit the entire spectrum what's the word? An uncorrupted signal, right?
Yeah.
Then it takes
That's
a
a
lot
good way to
more.
put it.
Yeah.
Yeah, and it takes a lot more to get it clear and clean too.
Right, through the
So
channel. Right, exactly.
if you're encoding something through, say, ham bands into a digital format, it's basically gonna sound like you're talking to somebody through a good cell phone connection if you're using the digital. Whereas if you're using an analog, AM back and forth, you both have to be pushing a lot of watts out the tip of your antenna to be able to hear each other clearly.
Right,
Because,
exactly.
it's all about, getting that.
What you push.
Yeah.
Yep.
I think.
And usually that's the trade-off too. I mean, you start trading off power for absoluteness of information because you are losing some data when you're going to a digital signal, but it's negligible these days.
Sure.
It's not that big a deal.
Sure.
And it also helps getting through that channel, like getting through the air. Basically, that actually affects the signal. So you gain something in having a digital signal where you can still resolve. If you have a 0 to 2.5 volt digital signal, and you can read that at one point it's 0.6 and the next point it's 2.1, then you probably know that the first one's low and the next one's high. So that noise doesn't matter as much.
I will accept said answers. Although I think that at some point, someone will learn how to, I don't know, optimize analog communication such that it's more powerful than digital and faster and less power hungry. I don't know how.
Yeah.
But
Anybody who knows anything knows that we don't really know anything.
any
So, you go
Is that
100
kind of
years,
recursive?
100 years at the, the rate that technology increases exponentially on itself, 100 years from now, who knows what we'll be doing?
Who knows?
Right.
We'll be making our own chips at home.
Ooh, touchy subject.
Now, I love these topics of like where technology has like put its feelers out and then said, yeah, not so much, and then gone over here. That with the analog math. I've also read about how some early computer scientists, instead of going the binary route, they were working with balanced trinary. Have you ever looked into that?
Balance? You mean like zeros, ones, and minus ones?
Yes.
Yeah, I know someone who was doing their master's thesis on that, so they're actually still doing it these days.
Isn't it just like trying to do math? Have you ever tried to do math in that number base?
Like tertiary math? No, I've. The logic behind it is crazy.
It is. I've
it's like
I've
you
played
start
with
messing with
it.
carry bits and stuff, don't you? I mean, isn't that kind of where it starts to get wonky?
Yeah, and just like when you start carrying negatives around and you're like, my brain is just running out my nose, run away, run away. It's awesome in the worst way possible.
That would be very bad. The zombies would quickly eat you, but from your nose. That'd be gross.
It was they used it up into the point where they started to get the first transistors, and then they realized that you can do a binary bit with one transistor, or you can do this trinary bit with two transistors, but there's only 3 values that you can get in a trinary bit, but with 2 transistors using binary, how many can you get?
Yeah. Yeah, that would be a role for analogs. I mean, it would never really be analog again, I guess. I guess it'd be just more discrete
Well,
levels.
it's digital, but it's, there's
Right.
3 instead of 2.
Right, and you could expand from there. Why not? Why 3? Why not 8? Why not 13? Right? Why
Yeah.
not try and use 1 bit to
So, you can use that, 1 bit that has more than 2 values, and it makes a lot of sense to do that because you can do, math much faster. But it doesn't make sense from the literal, I have to build this on a die point of view,
right.
because 2 transistors equals 3 values in trinary, 2 transistors equals 4 values in binary. So transistor count-wise, it's not as efficient.
All right, y'all are just being confusing.
Oh, sorry.
Well, actually, a good example that actually does happen. Like something with those discrete levels, that does happen, and it happens in a place I used to work at Samsung, and I used to make flash memory, and that's actually something they do. I don't know if you guys know do you guys know how flash memory works at all?
Somewhat, not in detail.
Nope.
It's pretty cool, actually. So it actually uses like a quantum physics phenomenon called quantum tunneling, where basically you have a barrier, you have like this physical barrier, and if you put enough charge on it, there's a statistical likelihood that some of the charge is going to tunnel through that material to the other side.
Sure.
Pretty cool.
Yeah.
And basically they use that they separate out this storage area away from, the regular, where the electrons are flowing, like a metallization or, a poly substrate or something like that. And what they do is when they want to store charge, they just kind of turn it on really high, and then they dump a bunch of charge through this barrier.
Mm-hmm.
And when the charge is in there, then they turn it off, and it just stays in there. And that's kind of the cool idea. You put it in there, and it stays in there, and then you can actually read it back without having to unload that little holding cell, if you want to think about it like that.
It's kind of cool that it's readable.
It is, yeah.
Yes.
And actually, that's why they say flash is like not, you can only get like 10,000 write cycles. It's because every time you do that tunneling, it actually destroys the barrier a little bit.
Interesting.
I always wondered why it was limited on how many times, and that makes a lot of sense, yeah.
Yeah. And it actually breaks down eventually, and then it will just fail catastrophically, and it'll just blow that whole area away. But the cool thing is, they kind of have that analog. It's not analog; it's just multiple discrete levels, really. And usually it would be like, if you think about it in coulombs, right? So coulombs being a measure of charge, maybe it's 17 coulombs that you can dump in there, right? That's probably the way wrong number. But you go from 0, there's 0 coulombs in there, or it's 17 coulombs in there, and you can calculate all that stuff and you can read it back. Well, the difference is, let's say 16, because that's a much better number for this calculation. What they started doing is they said, well, we could actually figure out a way to just put in 4, 8, 12, or 16, right? Mm-hmm. And then you have 4 discrete levels in there. And so they actually have it now where it can store effectively 4 bits in a single level. Mm-hmm. And they love that, because then you can store 4 times the amount of data in the same area. And Moore's law loves that kind of thing. So they made a buttload of money doing that kind of thing.
Interesting.
But it's really cool. It's called MLC, multi-level charge, I believe, versus single level charge.
Very cool. Well, it's cool that they can quasi-control it, I guess.
Yeah. It's interesting.
How difficult would it be to rebuild back up to that technology if you didn't have the like the current production stuff? Like if you wanted to cook flash memory back up again, how would you get back to that point?
If you wanted to cook it up like after an apocalypse?
Like from scratch, yeah.
Oh. Well, it's kind of hard to think about, because it's like, if you ask me how I'd do it, I'd say, well, do it the way they're doing it now. It's like you figure they have the most efficient method of doing it, but it's not very efficient at all.
I imagine their method relies greatly on scale, doesn't it?
Today, yeah, it's very, very small scale stuff. Or scale, you mean like economies of scale?
Well, economies of scale, and the fact that they have the machinery to do things at such a small scale on such a large scale.
Right. Yeah. I mean, so I guess if you're going from caveman to 16 gigabyte flash, that's kind of the idea you're going for here, right?
Yeah, I'm just wondering. I mean, it's a cool storage medium, and one of the things that we haven't talked about yet on this show is we've talked about rebuilding computers, we've talked about rebuilding energy, power grids, all of that kind of stuff. How do you grow food, whatever? But we haven't talked about a good way to build your own new storage stuff. So this is actually interesting to me.
Yeah, I mean, even if you look at hard drives today, like getting back to that point would be extremely difficult. So, 10,000 years down the road, say today, zombies attack, because that's the premise here, right? And we lose.
It's the truth.
It's the truth. Okay. Shoot.
Shoot the zombies. That is correct.
That was another thing I was going to mention. I did learn how to shoot this weekend, but we can come back to that.
Awesome. We got turret guns.
Oh, nice.
We'll have you set. But continue before I make you forget your train of thought.
I really don't know how you'd get back to that point. I mean, I guess you'd have to build back up. I mean, it's a very complex device, but really,
I'm not going to be stingy here either. It doesn't have to be flash. What do you think would be a good storage medium if you had to start from nothing?
Well, I do like the idea of the memristors. We were talking about that on the show last night. I mean, I love the idea of it, and that's poised to replace flash.
Yeah, I like the ideas that are coming out of HP.
Yeah, well, that side of HP is the good side, but yeah, the rest of it's kind of in the toilet, but. That's a different show.
That's their nest egg.
Yeah, I don't know how I do it though, because I was reading about silicon today, and it's like silicon really it's just so abundant. Like it makes so much sense from a raw elemental standpoint. Of if we were starting from scratch today, you'd look around and you'd say, well, maybe we should make things out of carbon or out of silicon, or I don't know, but silicon would probably come out on top, I think, just because it's everywhere. It's sand, if people don't know. I mean, like that's what sand is, silicon dioxide, right?
Now getting it refined, that's another story.
Right, exactly. Getting to that point where you have, 99.99999% purity. Yeah, you're not going to be doing that with a fire, They can hardly do that in Japan. I mean, like it's hard. It's a hard thing to do. And then the economies of scale, like you mentioned, Whisker. It's just getting back to that point where you can make a 300 millimeter wafer, or now like 450, like they're talking about, which is 18 inches across. That's an extra large pizza, and all the processing equipment you need, and all the photolithography, and all that other stuff. It's just it would be very difficult. So. I guess I would start with, if you could do memristors, that'd be cool. That's a pretty fancy material, though. That's like titanium dioxide.
Yeah, they can barely make that stuff now with the, the most advanced research equipment available. So I don't know how viable that's going to be.
Right. If you're going large scale, maybe if you were, because they're trying to scale it down to a really repeatable, really economical standard now, right? Because they're already competing with flash with memristors. Excuse me, but yeah, I guess I would start with memristors if I could. That might just be fresh on my mind. I think after that, though, if you could have some kind of, you could do ferromagnetic, so you could, and that's how they used to do memory. That was, but that's going to be, you could fill up an entire house with ferromagnetic memory at the size that you'd be able to carve it out with, and you'd be storing a solid text file, right? I mean, like maybe 1-2 pages of text. Maybe.
Hello world.
Yeah,
Great.
just about. I mean, you think about how just the amount of data today, it's just we've gotten very accustomed to it, with
Right.
high-level programming and everything else.
Right.
So, if you were trying to go really small, though, I mean, I think the future today, and the future maybe in the future even, would be, like a biological organic transistor and having some kind of storage element there. But again, that having just a transistor doesn't matter much. You could do like a DRAM where you store information on a capacitor, right? You could create a bio capacitor really with like a electrolyte and two conductive gates, but then you have to you have all the problems you have with DRAM. You have to keep it charged, and you have to sense the voltage on it, and then refresh it, and all that other junk. So, to answer your question, I have no idea.
Questions like this,
paper and pencil.
Questions like this never ever have a really good answer. But they do always open up a flashlight on various aspects of things that we all take for granted for granted every single day. The fact that we have this very easy access to all of these chemicals and raw materials that are not easy to get.
Oh no.
They take energy to get. You know, and if it's just a small group of people trying to do something from nothing, it's out of the question. You can't get that stuff because you simply don't have enough potential energy and work power to be able to harvest everything that you would need to do it.
Right. Yeah, that's interesting.
Which brings me over to the Open Ecology project. Those guys are working on some stuff to try to make it so that small groups of people can build up a base.
And not necessarily just for the zombie apocalypse, but also for lower income areas that might have access to raw materials, but not necessarily refined machines. Which I'm in love with that project. I think it's great.
Yeah, I think it's a wonderful thing, and I think it's great that somebody has gone out of their way to recognize that the problem in a lot of places isn't necessarily that there aren't materials, that there aren't resources, but the problem is that the people who are sitting on those resources have no way to get them, no way to refine them, no way to turn them into the things that they need.
Yeah. Yeah, it's I thought about that project and how I might be able to contribute to it. And I think one of the key pieces that they're missing is they have a lot of Arduinos, they have a lot of high level control like that because it's cheap, it's accessible right now. But I think at a gradual stepping back actually from a microcontroller based control unit to maybe like a multi logic level gate, discrete logic controller, something like that. Make it simpler, make it replaceable parts easily. Because right now, AT Mega 328, right? The stuff in an Arduino, right?
Yeah.
They have a lot of trouble getting those right now, and
there's only been like 360,000 units sold on those, right?
Right, exactly. And so there's no real buying power. There's no guarantee of the parts being there tomorrow.
Build it with 555s, man.
I mean, yeah, you could do something like that, but then you even have to step it back from there eventually. I mean, eventually you do have to kind of work it all the way back. If you could work it back to a transistor level where you either build you build an effective microcontroller, which would be very complex, or you build a discrete logic controller with 7/4 series logic or something like that, with the hopes that in the future that someone like Jerry Ellsworth printing a logic gate at home. I think she was working on a NAND gate last time she was doing chip stuff. And then eventually that does become a reality where you could make your own stuff at home even.
Right.
And that's kind of what I know that Arduino is amazing. It's a very open platform. It's got a lot of great uptake, and it is kind of inspiring people. But I think eventually it does have to move that way if they want to be serious about a very low cost, very accessible electronic set that can go along with this mechanical set, because the mechanics alone, or the mechanical component alone, is a very difficult challenge, right? Yeah. But the electronics are just kind of like a hand wavy kind of thing. They say, oh well, yada yada yada, and then we flip a bit, right? And it's like, well, that's good, but if you were really building from scratch, if you were in rural India and you had nothing, then what are you going to do, right? I mean, if you just had metal, that's kind of, I think that's my example. That's what I think of. Yep. And you're kind of screwed at that point.
And a lot of people look at this sort of thing like it's impossible to do it if you can't buy it in a store. How do you think the guys at the store got it? Somebody made it, and they gave it to them to sell. Okay, yeah. All of this stuff is possible. It's possible to do this stuff yourself in your house, but it's not necessarily easy.
Right, it's not easy and it's not cheap, and it's not elegant either. That's another elegant solutions are are very hard to come by.
Right.
And I think microcontrollers kind of have the air of elegance because they do. You write this code and
It
you
works.
yeah, you just kind of outputs a input stimulus, output stimulus, right? That seems like elegance, and it is to a certain level, but at the same time, it's like if you don't have that, then you can't be elegant anymore, right? I mean, like you're screwed. You're screwed. So I would say that's another challenge they're going to deal with, and we all know my position on printing chips at home, but people could argue, how are you going to print chips at home if you don't have any of the raw elements? And I would nod my head and say, yes, I have no idea. But,
yeah.
But I think it's interesting to consider because that also shows in some ways how much you understand about what you're working with. Like it's real. Like even if you look at a transistor, like I don't know 555. Let's say for instance, I mean, how many components are within the 555 to enable it to do what it does?
Probably like 5 to 10 resistors, bunch of logic gates, and some BJTs. So yeah, maybe.
And then within those
40 components. Yeah.
Yeah. I mean, 40 components for this one chip. Like.
Yeah, if you want to break it down to transistors, right? Yeah,
right.
And then making one transistor is hard. So.
And that makes it. I don't know, like, because I love schematic.
It would be kind of fun to build a 555 from
go for
discrete components.
Yeah, actually, some people did that during the contest. Some people did build them up. So
yeah, that's awesome. And it's so much more fun because then you kind of get just that much more of an understanding of how it works. You see where the signals are. You see what they're being influenced by, kind of, to the best that we can understand it. And I don't know, like, I think when you understand more, you can utilize it more. Like, you can do more.
Yes, I think the reason why a lot of us feel that way, Eddie, is because we're living in a period where the curve of technology advancing is moving faster than our generations are going. So even within any of our lifetimes, technology is completely different, from life stage to life stage. So it's very easy at any given moment to think, okay, we're no longer rooted to the way it used to be. This is how it is. This is how it's always going to be until next week when it's different. Then this is how it is. This is how it's going to be. And we've lost connection with that root, that seed that allows everything else to grow up from it. And those of us who are actually like aware and interested and engaged inevitably seem to go down this rabbit hole looking for the root.
Yeah, it's interesting. If you talk to some old timers too, a lot of them who are working in like the embedded world too, and I completely agree with them. They grew up working on hardware, and then they usually migrated into working as software and even assembly level or moving higher into C. They know how compilers are working because they had worked with the compiler. They had worked in assembly before they were working in C, or before they were working in assembly, they were working with discrete logic. So these guys have that experience behind them. They know how computers are built. They know how circuits are built, and yeah, you're right. When people come in with this assumption of, oh well, it just works below the decks, right? You need to dive down into those decks to actually learn it, but I'm not sure if there's really a push to do so these days until some kind of stimulus, which I'm not sure what kind of stimulus there could be.
Zombies gnawing on your brain will be stimulus.
Patty has the answer. That
Always.
would be one.
She does have zombie on the brain, I gotta say. Yeah.
Brains. Yeah. Speaking of which, Addie has a tradition on this show of as we get towards the end here, we just sort of turn it over to her to let her go off on her little grill. Yes.
Oh my gosh.
Is this like rapid fire?
The little grilling of the guest. She's got a few questions for you, Chris.
Yep. Now, I might add a few extra ones because I can't believe we hardly touched on the amp hour. But
who cares about that?
So, quick question, which I'm sure this could be answered really quickly. How did you hook up with Dave to start the Amp Hour?
Reddit, actually.
Oh, you just...
Someone asked if there were any podcasts, and I said no, but I'll try one. And people can find it on my site. It's probably the worst thing you'll ever hear. And then Dave was already doing his thing, and then I sent him an email, or he sent me an email, and we said, hey, we should try it together, and we tried it together, and it seemed to work. So
awesome.
That was that.
Awesome. Okay. So you and Dave kind of have your pulse on kind of the news that happens in electronics pretty generally.
I think they're faking it.
So we are. Yeah.
So what do you think is exciting people the most in electronics at this point in time? I mean, that's obviously very general, but
yeah,
if you could pick
general,
anything.
Well, from the lens I have, I think can I just answer what's exciting to me?
Yeah, absolutely.
I mean, exciting to me. I was talking about last night. I mean, open source hardware is very exciting to me. I think that's a crazy field.
Yep.
Yeah. Other stuff. I mean, low power is crazy, like power efficiency stuff.
Mm-hmm.
I talked to some vendors that are just going gaga over it. I was talking to some that were talking about silicon carbide, gallium nitride, just like more exotic materials that are moving into the mainstream. I think that's going to be a big deal. Just a lot of power efficiency stuff too, even LEDs. I think that's
cool.
Yeah.
Cool.
And I like printable electronics too, but I don't think there's a lot of interest in that outside of me.
Printable electronics are pretty neat. I've done a little reading on that, and it looks like something that'd be kind of fun. Okay, so since I'm into ham stuff, and ham is so much analog, and a lot of obviously RF.
Yeah. My RF knowledge is weak.
It's actually not that bad. It really isn't. It's
Okay.
just.
Well, if you're
I
good
don't know,
at
it just kinda
analog
makes
circuits,
sense.
then you're going to be natural at any
Yeah.
of that kind of stuff.
I keep hearing that, but I haven't done enough yet to really.
So why not?
Why that was the question. Why haven't I done it yet?
Mm-hmm.
Well, I didn't do when I was younger because I didn't really have any. I didn't really get into electronics till I was in college, and so usually a lot of people get into ham because they have a mentor,
A dad or something. Yeah.
yeah, a dad or an uncle or just a friendly neighbor.
Sure.
Yeah, so there was that, and then why hadn't I gotten into it in the meantime? I mean, that's the thing. That's one of the problems with ham is the mentoring system is so good. It is just so incredibly like strong. The Elmers are so
They're
that's such a
awesome.
strong culture.
Yeah.
But it's just how do you get people involved initially? And there's nothing there. I mean, like it's getting a little better. I really like that Leo Laporte's got that Ham Nation show now.
Yeah.
I don't know if you guys watched that.
Yeah. With
Yep.
Bob Heil.
Bob Hyland and Gordon Moore.
Gordon
and
West. Yeah.
Yep.
Gordon West, is that it? I thought it was.
Yeah.
Oh, no,
Yep.
Gordon Moore is the guy from Moore's Law, right?
Yeah. We're familiar.
Right. And that it's great. I mean, it really is. And having some kind of mainstream interest and people really take to the hobby once they get into it.
Right.
Why I haven't done it yet? Well, there's mostly just trying to sleep at some point in my life, and
For the week.
it is.
You got to be pretty.
I can understand
you
that.
Can't have been out of school too long, right?
Me? I've
Yeah.
been out since 2006.
Okay, so a couple years.
5 years.
And
yeah.
fiance to
honest-
marriage and starting
Yeah.
a business and all that. I'm sure you've been pretty busy.
Yeah, to be honest, when I was working at Samsung, there was no circuits there. I mean, I was in a fab. I was a process engineer, so that was I made a very conscious decision to try and get back into electronics when I moved back to Cleveland, and I made the move only because of that. So, and I'm really glad I did. I mean, I wouldn't be doing anything I'm doing today if I had to move back here. So, go Cleveland.
Buckeye State.
That's right. Yeah.
Okay, so these are now my actual questions.
Oh, now we're to the actual questions. I see.
Now we're actually to the
Before it was practice
It was
questions.
just practice, just warming you up. All right, zombie apocalypse. What 3 tools would you take to your zombie apocalypse bunker?
I should have thought of this beforehand, huh?
No
'Cause
worries.
you asked this in all your zombie tech
Mm-hmm.
episodes.
But that's okay.
I would bring. Oh, see, that's the thing. Everything you bring would need some kind of material resource or some kind of raw material, right?
Yeah,
Well, just
Jeremy
try.
Blum last week, 2 weeks ago, was talking about bringing his MakerBot and filling it with boxes of seeds of genetically engineered corn that he could use to make corn-based plastics that he could use to make
That's not bad.
stuff for his MakerBot to make stuff with that he could use to make pots to grow his corn in that he, just
Right.
around and around. It's like,
Yeah,
brilliant little
that's pretty
bastard.
good. Those Cornell kids, they're pretty smart.
So
I guess
you're not
some
going to
kind of
top
weapon,
Jeremy.
I guess. So
you
I
know.
probably need some kind of weapon, like a gun.
Yeah.
And
And you
I
had
learned
the
how to shoot a shotgun.
That's
last week,
right,
and
that's right.
That was fun.
No ricocheted shots embedded in your skin or anything like that?
Was that your
I
first time shooting?
I had never shot a gun before. And,
Aren't you a Midwesterner?
I no, I'm a suburbanite.
Uh,
But my wife grew up on a farm,
Right,
and her
right.
family has lots of guns.
cool.
And so, really, if there was really a zombie apocalypse, we're going to her farm. I mean, that's the real thing. They've got
Fair.
guns, they've got food, they've got
Fair enough.
not many neighbors.
That's a good call.
Yeah, so that's always been the plan. We've actually talked about that in a world crisis situation. That would be our
That's
our,
your
uh,
go-to.
Fall
Yeah.
shelter, fallback shelter.
yeah.
Very nice.
You know,
I wish we
there's lots
had a
of
place
places to
like
walk,
that.
and there's there's cows, and it's so picturesque.
As long as the cows aren't trying to eat your brains. Yeah.
You guys and the brain eating. I don't know.
That's awesome.
That's right.
So a gun.
A gun.
Yep.
Big bag of gummy bears.
Excellent.
And a case of Great Lakes beer. Have you guys ever had Great Lakes beer before?
I have not.
Oh, it's great. It's the Cleveland beer. It's they've got a bunch of great ones. My favorite is Edmund Fitzgerald. It's a porter based on a ship that's sunk in the middle of Lake Erie. And it's a delicious beer.
Whiskers
I've heard of that
nodding and
ship.
Smiling.
Being a Michigander and all.
Oh, yeah. Michigan's got a lot of great breweries too. So
Yeah.
I'm a big
And
fan.
here in Minnesota as well.
Oh yeah? I've never had any Minnesota beers.
Yeah, they make some good ones. You got to get some
Whiskers
is it
accents.
Blue Moon,
Blue Moon's good.
like wheat ales and such. Those are
Yeah.
pretty good, especially
But
this
Blue
time
Moon's
of year.
a big brewery. That's owned by Coors or something, I think. So
Well, yeah, there's lots of other ones that are they make similar stuff, but microbrewery size runs around here.
that's great. That's great. Hopefully that will survive through the zombie apocalypse. Because the water would be not so clean. So like in the olden days, you would want to drink beer or wine
Yeah,
to make sure that the water's safe.
there was good reasons for that
Yeah,
invention
and then you
back
party
in the
all
day.
the time, right? You have to celebrate being alive and not having your brain eaten. So
Absolutely.
yeah.
So beer, gummy
Gummy
bears, and a shotgun.
And a shotgun.
I want to switch out gummy bears for Cheetos, like a really big bag.
Because you're not getting any more of them at the farm.
That's good. Yeah. There's a lot of corn out there, but yeah, it'd be a long time to wait before I got cheese powder. So.
That's just to entertain yourself on the drive to the farm. I gotcha.
Well, you could get milk and then,
Yeah, pasteurize it. And
yeah,
do
there you go. Get cheese and then somehow
dry it out and
dry
grind
it
it
out.
up. And,
There you go. Cheese powder.
I'm thinking
go.
Chris's plan isn't that bad, actually. Because, he's going right to the source of old school technology, the farm.
Yeah.
Because that's
Yeah.
what's going to work at the end of the day.
I guess that's
Yeah.
true.
Good
There's
stuff.
deer to eat, make some nice deer jerky. That's pretty delicious. So.
Oh. You've had deer jerky?
Yeah, it's great. Yeah.
Who hasn't had some venison jerky?
I've
Me?
had goat jerky before. It's
Oh.
Nah, that's a bit weird.
Gosh.
they sell that at a market around here.
Does it taste like chicken?
Why would
It tastes like spicy. It tastes like a Slim Jim, basically. I mean, it's good.
Oh. Tastes like mixed meat.
I bet if zombies were eating people jerky, it would taste pretty similar to every other type of jerky, honestly. If you get the right spices.
We used to make goat cheese in mason jars when I was a kid.
Nice.
You just shake
Nice.
it. She's got the
tried.
best look on her face right now. That wasn't even the funnest part as a kid. The funnest part was getting that milk into the jar.
Oh my gosh.
Yeah.
It's like,
Well, that-
you want me to do what now?
yeah.
All right, what's your next question, Addie?
Okay, I got one more question, and then I do have some real life questions, I suppose.
Okay.
Okay, so what would be the first system you would want set up at your zombie apocalypse farm?
The first system?
Yep. Like
Netflix? Streaming might not work. Do you think they'd still ship me discs? Switch over to the 4-disc model?
I demand the 1 business day turnaround time.
That's right, yeah. Make sure that mailman
Zombie
gets
couriers.
here safely. Yeah.
That would be great. I mean, their prices might go up just a little bit.
Those delivery men
for
would
insurance
definitely.
purposes.
Those delivery boys would definitely need to be quick.
Be
Book
packing
it.
heat.
Quickster.
Yeah.
Yeah, quick
Hey!
Ooh.
Hey.
name would make sense.
Hey, I'm telling you, it is
I'm onto something
foreshadowing. Netflix was foreshadowing the zombie apocalypse. They knew.
Yep.
They knew. That is flipping brilliant.
It's like the Pony Express for movies. I love it.
Yep.
Okay, so
First system, probably water purification.
okay, yep,
I knew how to figure out how to do that.
I approve.
Charcoal based.
I guess so. Yeah. I mean, they would charcoal, or you could do a evaporation, and then like a condensation.
Yep.
Like that Dean Kamen one. Have you guys ever seen that one?
No, but
There's
I've
this
looked
there's this
for
brilliant video of Dean Kamen being on the Colbert Report, and he's showing like how Decker Research, worked on this new water purification system. And Stephen Colbert, it has this tank of quote unquote dirty water. It's like red, it's got red food dye. But then Stephen Colbert dumps Doritos in it, and Dean Kamen shows that he can even purify that.
Oh my gosh.
It's brilliant. But the product itself is amazing. I mean, it's Decker Research is very awesome.
We'll have to take a look at that. I'm all about water purification.
Yeah.
Cool. Okay, so real life questions.
Okay.
For those who don't know you, I just wanted to go through the sites that you cover really quickly, and if you could just let us know what it covers, roughly, what it covers and what you do with those sites, that would be great. So,
Okay.
Amp Hour.
Amp Hour is an electronics podcast. It's me and a crazy Australian named Dave Jones, and he's awesome. And basically, we argue once a week for about an hour, and sometimes we bring guests on.
Okay.
And we kind of cover news items. We cover industry news. We cover open source hardware kind of news. Anything that kind of strikes our fancy.
Okay.
So.
And the guests basically are there, like, the one friend that's left of an abusive couple.
Sometimes, yeah, but usually the guest is talking nervously in order to ignore the arguing couple. So. I think we got maybe a paragraph and a half in edgewise with Joe Grand. He was a chatty Cathy, and we loved it because he just has so much stuff to talk about. He's great.
Awesome. And that's theamphour.com?
Theamphour.com, that's right.
Okay.
Yeah, we'll probably try to hit up Joe Grand one of these days.
Yeah, he's a great guy.
He does a lot of propeller stuff, and we're into that.
Yeah.
So
Yeah. That's awesome.
Now, www.555contest.com, is that still active?
It's still around. It's not really active. It's,
Okay.
I just cleared out some spam the other day, but
Okay.
that is a contest me and Jerry Ellsworth ran back in February through April.
Yep.
And that was a 555 design contest. It was completely independent. We got a bunch of third-party vendors to donate gifts, and we had Forrest Mims, the guy that wrote the engineer's notebook, and Hans Kamenzin, the designer of the chip, as our judges, and Phil Terone and of Adafruit and Wendell and Lenore.
And I had to say, I think you guys
SL.
kind of set the standard for how contests like these electronics contests should be run.
Yeah.
A lot of the subsequent contests that people have really gotten into have been largely popular vote, and that's gotten a lot of flack.
Fail.
Yeah.
Yeah, you can game that system pretty easy.
Oh yeah.
Yeah. The thing about contests is it's like the one thing that you really need is you need a bounded problem. That is the thing I always tell people. And that's the only downside about that the 74XX series logic competition that
By Dangerous Prototypes.
Dangerous Proto. It's a great idea for a contest, but it's just not bounded. It's just like, oh, I'll do anything.
Right.
And it's like, well,
That's a
That's
lot.
kind of a tough problem, right?
Right.
The contest I'm still waiting for is that I'm not going to do is um, like a pick, like a real small memory pick, where you can shove a lot of stuff, a lot of function into a small memory.
Yeah.
And I think that would be, or even if like propellers, if parallax would do something like that, just a very bounded problem is a good idea.
Yeah.
So
Yeah. Okay. Engineerblogs.org.
yeah, that is that's kind of like the softer side of engineering. The softer side. No,
It's like toilet paper.
yeah, or the Sears commercial. That's what I was thinking of. Yeah. Basically, it's just kind of engineers writing about engineering issues, but not necessarily technical. Sometimes there's technical stuff, but it's me and 5 other engineers, I believe,
Okay.
and we try and post each once a week in, just engineering type topics.
Yeah, and usually they'll tweet them if they're particularly good or something. A lot of the folks will tweet them. And
I tweet them no matter what. If they're crappy too,
yeah, they get
try and stop
retweeted
Retweet
around
them.
the community quite a bit, and you definitely notice them when they come up.
Cool.
I'm glad that happens.
And then finally, chrisgammell.com.
That is a dumping ground of all my old stuff. I kind of stopped working on that when I did engineer blogs because the amount of work it takes. But
Right.
that's a lot of the old articles. That's where I started and stuff. That's where I started writing, and it's fun. It's a lot of old art. That's where Addie, you said you saw the op amp articles. I did some technical stuff like that.
Yep.
Just trying to bring it to a easily recognizable level, and there's some fun stuff on there, but mostly it's elsewhere these days. So I'm hoping to
Gotcha.
come back to that eventually.
Gotcha. Oh, and you know what? I almost forgot. Last one, analogelectricalengineer.com, or if you just Google Analog Life LLC. So, what can people who would be interested, like, what are the type of clients you get? What type of people do you serve?
Do you work locally? Can you do consulting over the net? What do you do?
Advertise your business.
That's all I've done so far is over the net. I've had one out in Utah and one in California so far. So
So if you've got big analog problems that you need taken care of, you can get a hold of Chris, and he'll let you know if you can handle it or not.
right, and that site I have to apologize for. It's kind of just a placeholder right now, but
No, that's cool.
eventually it'll get more updated and stuff. So
Yep. No, that's cool. Okay. So I think those are my quick questions, and I think you can be found on Twitter at Chris_Gammell.
that's right. Yeah,
Yep. Gammell.
that's right. 2 M's, 2 L's. That's
Cool.
it gets spelled wrong a lot. So
All right.
I'm used to it.
I think that pretty much wraps up our hour. So
Yeah, that flew by, huh?
Yeah.
Yeah. Thanks for joining us this week, Chris.
Yeah, it's my pleasure. Thanks for having me.
Yeah.
That was one of the fastest hours yet. All right. We'll see you all next Thursday.
Yep.
Bye.
Bye.